Hi, my name is Adib. I'm from KIT Germany. We are working on UV illuminated tin dioxide nanowire-based electronic nose. An electronic nose is a device that can identify smell, like our biological nose. But there is a catch. Our biological nose has 30 million smell receptors, but instead we have only 16. So we are not as good as our biological nose, but it works. So let's see how it goes. We try to make a product for consumer electronic, and that's why we have to be very cheap. So that's why we're using printing technology to produce our device. And it also has to operate at low power. We need approximately 7 milliwatt to activate such device. And another big advantage of our device is that we can work in room temperature, which is a big advantage for a lot of applications. So this is how it looks like. So as you see here, we have printed gold electrodes on ceramic substrate, and then we disperse tin dioxide nanowire across those substrate. And then we illuminate those nanowires using UV LED so that the nanowire becomes gas sensitive. And then we measure the change of resistance of these nanowires using some electronic. And afterwards, we use pattern recognition algorithm to teach the device different smells. We have a lot of application that we can think of. We have application from waste management to chemical industry. A very good application can be a smart fire alarm. So if you think about like this, a normal fire alarm works when smoke breaks out and it goes inside the chamber, and then it triggers. But as we can detect smell, we can identify the source of the fire from the change of smell, which is a very good advantage for firefighters. It can give them a significant amount of time to react, which can be a very nice application of such electronic nose. As you can see here, we are using tin dioxide nanowire, and we grow those nanowire on black silicon, and then we disperse the nanowires across the segment randomly, as you see here. And then we use LDA, linear discriminant analysis, as a pattern recognition algorithm to teach the setup with different kinds of smell. Now, let's have a look into our device. So this is the demonstration electronic device, which measures the change of resistance of the sensor. And the chip is inside.
Now I will show how our electronic nose work. On the left side, we have the LDA model, which is trained to identify 3 types of smell. The red circle is the smell of a lighter, the green circle is the smell of the demonstration room, and the black circle is the smell of a deodorant. The blue dot is a real-time data point on the LDA smell map. On the right side, we see the median resistance of 16 sensing segments. When a target smell will be introduced to the vicinity of the sensor, we should also see immediate response in the median signal as well as in the LDA plot. Now I introduce lighter smell to the sensor, and as you see, it immediately responded to the smell. And the real-time data point shifts from the green circle to the red circle. And it will also recover very quickly.
And when we use different smell, it can also be taught online, real time, and that is very helpful. Thanks for joining us.